Number 8 asks, if you add 100 nanomolar drug to a protein sample that contains 10 nanomolar protein, you find that 9.5 nanomolar of the protein ends up with the drug being bound. All right, what is the KD for this interaction? All right, so the equation we want to use here is our fraction bound is equal to our concentration of ligand divided by the KD plus the concentration of the ligand. All right, now this looks very similar to the equation that we see in hemoglobin, where instead of concentration of ligand, because we're talking about gas, we talk about the partial pressure of oxygen, the P50 value, and then partial pressure of oxygen again. But these equations essentially look the same. Just understand that the partial pressure of oxygen is the gas equivalent of the ligand concentration, and the P50 value is the pressure version of an equilibrium constant. All right, so we'll just cross that off. All right, so we have this equation here. This is just dealing with now things that are soluble rather than soluble non-gases. All right, so why is our fraction bound? Well, what is the fraction bound here? Well, the fraction bound is simply the amount of our enzyme with the ligand bound divided by our total enzyme. Well, in this problem, we're given both of those. We're given that we have 9.5 nanomolar of our protein has ligand bound, and our total amount is 10. So this equation here then just becomes 9.5 over 10, or 0.95. So that's our Y value. So 95% of our protein has ligand bound. All right. Now, the other piece here is we're given L. We're given the ligand concentration. So the only thing we don't know now is KD. So our equation looks like this. 0.95 equals 100 nanomolar. Write that a little clearer. Nanomolar divided by our KD plus 100 nanomolar. All right, now we have to do some algebra here. All right, and this algebra is a little bit more complicated than other things that we do. What we're going to do is we're going to multiply both sides of the equation by this denominator. So both sides of the equation are getting multiplied by KD plus 100 nanomolar. All right, so if we take, so what it looks like then is we have 0.95 times KD plus 100 nanomolar is equal to 100 nanomolar. All right, well now we have to multiply through. So we have 0.95 KD, and then this part here will become 95 nanomolar. But if we multiply through, we end up with 0.95 times KD plus 95 nanomolar equals 100 nanomolar. All right, and we now want to subtract 95 nanomolar from both sides, so we're going to move this over here by subtracting. All right, and what we're going to end up with now is our 0.95 times KD is equal to 5 nanomolar. All right, so now we can divide both sides by 0.95, and we're going to end up with KD is equal to 5.3, oops, sorry, keep the units the same, nanomolar. And that's it for that particular question, question number 8.